there weren't enrolled in the course, you'll use it there as well. So, first of all, square roots. Normally, the index of 2, this is called an index, is omitted, so you normally just see this symbol, and that would be also considered a square root. If there is no number, it's understood to be a 2. Some of you that have been in Algebra 2 or have are currently in it have seen cube roots, where you see a index of 3, or fourth roots, and so on. We will work with some of those later on in the year when we do volume. But for right now, we're just looking at square roots. So, to simplify a square root, you want to find the largest perfect square that divides evenly into the given number. And I will give you a list of the perfect squares up to 25 squared. You don't get to use this on any quiz or test, so you have to memorize your perfect squares if you don't have them memorized already. 1, 4, 9, 16, 25, 36, 49. All I'm doing is squaring numbers. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 25. But this sheet are all the ones that you should have memorized and be able to know without a calculator. So when you're breaking the numbers down, you don't want to break them into just 2 numbers that multiply to get you that number. One of them has to be on this list. It has to be a perfect square. And I have the first few, that 1, 4, 9, 16, dot, dot, dot. That divides evenly into the given number. You will factor the number into 2 square roots, and then you will take the square root of the perfect square. Okay? If you don't take the largest perfect square, for example, you may have to keep reducing. So you want to check the non-perfect square to make sure it's not reducible, meaning it's not divisible by a perfect square. If so, you have to kind of keep going with like a factor tree. And then once you take the square root, it will go in front of the remaining square root. Okay? So the rules, no perfect square factors under a radical. And my tip is to always look for the largest perfect square. So many of you, when you look at 72, you will think that 9 and 8 are factors that multiply to 72. That is correct. However, 9 is not the largest perfect square that divides in evenly. So if you're not sure, you could take your calculator, 72, and start dividing by perfect squares that were closest to it. So 64, nope. 49, nope. 36, yes. Okay. So if you were following the rules specifically, you would break this into the square root of 36 and the square root of 2. Now, I suggest putting the perfect square first, because once you take the square root, the number is going to stay in the front, so it's kind of useful. Then we take the square root of 36, which is 6. What squared gets me 36? 6. It now comes out of the square root. The square root of 2 we don't know, and it's also not reducible. So our answer is 6 root 2, or 6 square roots of 2. The 2 ways you can say that. Now, let me just show off to the side. Some of you would pick 7 or 9 and 8. It's not wrong. You can do it this way. It's just a longer process. So if you were to choose 9 and 8, you would take the square root of 9, which is 3. And then the biggest mistake is that you'd circle this and then move on. The square root of 8 is never done because it has a factor of 4. So if you did it this way, you'd have to keep reducing. The 8 would break down into 4 and 2. Make sure you only take the square root of things you know the square root of. Like, you don't know the square root of 2. You know the square root of 4, which is 2. And then any outside numbers that you're left with, since there's no operation, it's understood multiplication. So 3 times 2 would get me 6 root 2. So do we see how much easier it is if you pick the largest perfect square? It's like a one-step process versus a multi-step process. So I would take the time to make sure you pick the largest perfect square that goes evenly. Okay, so I have my perfect squares listed up at the top. Again, these are something that you may want to write at the top of your paper until you get comfortable with it. Those of you in Algebra 2 probably are comfortable with these numbers because you've seen them a lot. But these are the numbers you want to think of. So for example, you would never, don't write this down, you would never want to write this. 2 times 10 is 20. But 2 is not a perfect square, 10 is not a perfect square. If you do this, you literally can't do anything else. So when you do it, one of the numbers has to be in the list. So the largest perfect square that goes in evenly would be 4. So I'll break this into the square root of 4 times the square root of 5. I always put my perfect square first because when I take the square root of 4, which is 2, it now becomes an outside number. It's like a coupon. You're reducing the number with a coupon. Once you use the coupon, it's gone. You do not leave the square root there anymore. 2 square roots of 5, or 2 root 5. Every year, someone will write this, which is wrong. It's a completely different answer. So please make sure that you realize numbers that come out of the square root stay out, numbers that are under the square root stay in. What would I break 18 down into? Right. You're jumping ahead of me. That's our final answer, yes. Square root of 9, square root of 2. Take the square root of 9, which is 3. And we do get 3 root 2. How about 3? What would I break it down into? Marquise? 9 and 3. And my suggestion is to always write that perfect square first. Write the 1, the 4, the 9, the 16, whatever. Put that first, because when you take the square root of it, it will stay in the front. So it's already right where it should be. That way you don't have to rearrange at the end. So 3 root 3. How many of you remember doing this in Algebra 1? See if you guys can try the next 3. Numbers get bigger quite a bit. All right, now in the back, we're going to take a look at multiplying and dividing square roots. So multiplying. You can multiply and divide any numbers that are both inside of a radical or both outside of a radical. You can think of them as like terms almost. So if they're both under square roots, you can multiply them. If they're both outside of square roots, you can multiply them. You cannot multiply an inside and an outside number. So like 2 times the square root of 3, you can't make that 6. So those will just stay there. So when you're multiplying radicals, that's exactly what you're going to do. You're going to multiply them first, and then you're going to reduce them like we did on the front. So these are both inside, so I can multiply them to get the square root of 18. And then I, again, need to think of my list, 1, 4, 9, 16, 25, 36. So this would break down into 9 times 2. Take your square root of 9, which is 3, and 3 root 2. Getting some of the same questions we got in the front. Now, square root of 2 times the square root of 10, square root of 20. What would I break that down into? Marquise? 4 and 5. 2 root 5. Now, for example 3, before you multiply those and make it 80, okay, which you can't. Welcome to do it. If you know what the square root of a number is, you might just want to take it, because then you get smaller numbers. So like the square root of 4, it's just 2. Then we have 2 square roots of 20. Again, if you prefer to do square root of 80, that's fine. Then you have to break down 80 into 2 numbers, one being a perfect square. But this way, I don't have to think about what's the largest perfect square that goes into 80. I only have to think what's the largest perfect square that goes into 20. So this would be 4 and 5. Now the 2 comes down and it just stays out front. And then we would take the square root of 4, which is 2. And again, this is understood multiplication to get 4 root 5. Again, if you don't like that, just keep it like this. But you'd have to break this down into 16 and 5, which is then 4 root 5. Last one, we do have outside numbers and inside numbers. So you want to kind of keep those together. We can multiply the outside numbers. 2 times 5 gets me 10. I can multiply the inside numbers. 12 times 3 gets me 36. Now, before you start reducing 36, always think, is it a perfect square? The answer should be yes. The square root of 36 is just 6. Now, if you broke it into 9 and 4, it does still work. But like, try to think of your perfect squares and have them memorized so that it makes your job a little bit easier. So we should get 60. So there's no square roots at all left in that answer. Okay, the last one we're going to look at is dividing these and rationalizing the denominator, because this is something we'll be seeing a lot throughout the year. Now, some of them will be written with a division symbol, some will be written with a fraction, but just like with multiplying, you can divide the numbers if they're both inside the radical or if they're both outside, if they're like terms. So this one we have the square root of 125 divided by the square root of 5. Well, this one's under a radical, this one's under a radical, so I can just divide them. What is 125 divided by 5? Square root of 25. Good. You have to keep it. If they're both inside a radical, you have to keep it inside the radical. Then we can take the square root of 25, which is 5. Now the next one. We have a big fraction underneath. Do I know what 4 divided by 3 is evenly? No. So at this point, what you want to do is you actually want to split this up into the square root of 4 over the square root of 3. Now, one of the rules in mathematics, both, I'm sure you see it in pre-calc still, you can't have square roots in the denominator of your fraction, okay? So what we have to do is we have to rationalize the denominator. Now to rationalize it, all you do is you basically multiply. The easiest way to do it is multiply by whatever you see down there. So to rationalize, we are going to multiply the numerator and the denominator by what's in the denominator. And you'll see what happens as soon as we do that. The square root in the denominator will disappear, because it'll become a perfect square. Now it's up to you at this point. You may just want to take the square root of 4, probably, up here first. Just make that 2. If not, you can leave it 4 and we'll simplify at the end, but that'll make your life a little easier. So to rationalize the denominator, again, all you do is you look what's in the denominator and you multiply by exactly what you see. So the square root of 3, whatever you do to the bottom of a fraction, you have to do the top so that it stays equivalent. Like 1/2, you multiply the top and bottom by 2, you get 2/4, which is equivalent. So we're not changing the value, we're changing the way it looks. Now I have 2 times the square root of 3. Can I multiply those and make it 6? No. So I'll just write 2 root 3. What do I get in the denominator? Right? You get 3. You'll actually get the square root of 9, first of all, and then the square root of 9 is 3. So the whole reason we call this rationalizing the denominator is it gets rid of the square root, because you end up getting the square root of that squared, which then comes back down to be this. So my final answer should be 2 root 3 over 3. Now, if these were reducible, we would reduce them, but they can't be. 2/3 is 2/3. Okay, the next one. Always try to divide. Before you start multiplying by the square root of 3, see if you can divide them. What is the square root of 36 divided by the square root of 3? Going to simplify to. What's 36 divided by 3? Okay, 12. Now we do need to keep this a square root of 12, because they were both under square roots. And can I simplify that? Yes, 1, 4, 9, 16, 25. This can break down into 4 and 3, which will be 2 root 3. All right, last one. That's a repeat for you. We just did, oh no, this isn't. Sorry, it's been switched. 2 more. All right, now 3 divided by 36 we can't do. You can reduce it to be 1/12 if you want to reduce the fraction, but I would probably split it. And the reason I'm saying don't reduce it is I know 36 is a perfect square. And so if you see those perfect square numbers, you want to look for them all the time. If they're there, you might be done. The square root of 36 is just 6. Can I reduce that and make it 1/2? No. I have 1 under the square root, 1 not under the square root. Those are not like terms. You can think of them like that. Can't be reduced. All right, now the last one, you have 2 options for this one. You can reduce this fraction if you'd like to be 2/3 first, or you can split it. It doesn't matter. I'm going to keep it as is just to show. But I can show it the other way too if you want. So square root of 4 over square root of 6. So what do you think I should simplify next? Maddie? Square root of 4. That's just 2. So I have 2 over the square root of 6. Can I leave that as my final answer? Am I allowed to have a square root in the denominator? No. So I have to rationalize this. And to rationalize, you just multiply by whatever's down there. Whatever you do to the bottom, you do to the top. Make sure you don't make this 12. This will just be 2 root 6 over the square root of 36, which is just 6. So every time you multiply by the same exact thing, you end up just getting what's under your square root, eradicating it. Now, the last step for this problem is we can actually reduce this fraction. 2/6 as a fraction would reduce to be 1/3. So this is really 1 square root of 6 over 3, or square root of 6 over 3. So if you do have 2 outside numbers, you can reduce those. See if you guys can try the 2 closures. So your homework is to complete just the front only, and then if you want any extra practice, it is on the back.